Hello guys, welcome to Samaliak YouTube channel, and today we are going to learn about analog electronics. In this analog electronics we have the common concept to cover like current, electricity and the potential difference. So let us start with current. Current, we know it is the rate of flow of a charge and it is vector quantity, or sometimes we say it is charge over time. Also, when we are talking about potential difference, we know that is we say is the difference between electric potential at two different points. Let us assume this is we have this is our circuit. Now the voltage at this point is not equal to the voltage at this point, and this potential difference is occurred most when the circuit is on. Yeah. So according to Ohm's law, we know the voltage across any resistance is direct proportion to a current flowing in a conductor, and that proportionality constant is what we call resistance R. Ohm's law, as I said, voltage across any conductor is direct proportion to electric current. Proportionality constant is what we call resistance. We have the common concept components in analog electronics. Here are some common components. The first is resistance, resistor. The second is capacitor. We have inductors. We have relays, valves. We have transistors, integrated circuits, chips. These are the sometimes we call the passive electronic components. Don't forget the first, as I said, resistor, capacitor, relays, valves, transistor, integrated circuits, and inductors. Now let's consider simple series circuits. This is a simple series circuit. Here this is ampere, this is a bulb, ampere. This it shows that here it means all the components are in series. Yeah. Also we have something we call the potential divider. Potential divider, it is occur when two resistors are in series and divided by volt output. For example, here this is we have volt in. This is sometimes we call voltage source, and this is voltage output. Now as you can see, we have R1 here and the R2. Now how to formulate a potential divider. The formula of this potential divider, assume now you want to calculate voltage output, this voltage output. Now we can consider this formula. Since this one we can look here, R1 and R2 are in series. It means the same current from here is flowing in this resistance, R1 and R2. Now if you want to calculate V1, you will take V1 is equal to I, then R1 plus R2. Make current the subject, then V1 over R1 plus R2, this one. Then after obtaining this one, let's refer to Ohm's law. From Ohm's law, voltage is direct proportion to current. So voltage is equal to IR. But now we are talking about the resistance across R2. So this voltage will be voltage output is equal to I, this current, but I we have already, this is, let us show this is equation 1. Let's substitute here, then times R2, and this R will be R2. Now for the case of potential divider, if you want to calculate voltage output, we use this formula, R2 over R1 plus R2 times voltage in, this one. Voltage output is equal to R2 over R1 plus R2 times voltage in, this one. This is a very important formula, so note this formula. We have the uses of potential divider circuits. You can press and read this one. the application of this potential divider. Also, let's move to Kirchhoff voltage law. Kirchhoff voltage law, KVLs. Here, in Kirchhoff voltage laws, we have the two Kirchhoff laws, which are Kirchhoff voltage law and Kirchhoff current law. So let's start with this one, KVL. KVL, here we just consider the voltage across a certain loop here. As you can see here, this is our circuits, and there is a voltage across this loop, and that is what we call voltage. Kirchhoff's voltage laws, and it is stated as the algebraic sum of all voltage in a loop must be equal to 0 here. So if you sum all voltage, we have AB, this voltage at AB, BC, CD, and DC. If you sum all voltage in a loop, must be equal to 0. So this is a simple expression or a simple statement of Kirchhoff voltage law. Now, important terminology to note here. I will show you this down, so don't worry. For example, here, if you move from negative terminal to positive, it is we call potential rise. But if you move from positive to negative, that is what we call potential drop. Negative to positive, potential rise. Positive to negative, it is what we call potential drop. We have also a current divider. Current divider, it is occur when the two resistors are in parallel and are in the same potential difference. So we can now if we want to find voltage, we will take IR, but remember I said the resistance must be in parallel, but under the same voltage. So voltage at this at R1 and current 1 is equal to voltage at current 2 and R2, because we said at the same potential difference. Now we can formulate. If you want now to find current 1, you will use this formula. Now, because we know voltage, we have stated here it will be I total R total. So I1 now it will be this one. This is the formula for current divider. Let's move to another Kirchhoff's current law. This is Kirchhoff current law. This is very simple law. In statement, we said any current entering the junction is equal to current leaving the junction. So the algebraic summation of all current entering the junction is equal to the current leaving the junction. As you can see here, all current enter, this is 1, 2, 3, 4. 1, 2, 3, 4. These all are entering to this junction is equal to the current leaving the junction, this one. So algebraic summation of all current entering the junction is equal to the algebraic summation of current leaving the junction. Now we can apply Kirchhoff's laws in solving many questions to calculate the current in different loops. This one application. Now let's consider this example. And calculate current 1, current 2, and current 3. As I said, the summation of current entering the junction is equal to the current leaving the junction. Now we can consider this one. This is the junction. In this junction, we have this current entering to this junction. We have I2 also, it is entering to the junction. It means this I2 is leaving the junction, this junction. So remember that one. We can formulate the first equation, this one. This is, let's say this is the first. Also, let's consider the first loop. This is our first loop. This is our second loop. Now, if we move, as I said, if we move from negative to positive, that is potential raise. So it is positive. But also, if the current is moving the direction with the loop, this is current of the direction of current, and this is the direction of the loop. Now if these two are moving in the same direction, it will be negative. Now let me show you this one. This is negative 10 I1, this one negative, this is current 1, this is voltage resistance 1, sorry. So they are moving the same direction, so it is negative, this one. Minus also, if we move to this side, this is R, this is I3, and this is R3, but they are moving, the direction of current is moving this direction, so we take as negative. So as you can see here, negative, negative, plus positive, positive, this one, because it is volt potential raise is equal to 0. This is the second equation from the first loop. You can move to this is the second loop. In this second loop, we have selected, this is the direction of loop, so we will consider this is if you start from here, this is 20 volt, this one it will be I2 R times 20, and it is negative because the direction of current is this direction, and the loop they are moving the same direction. Also this one will be I3 R times 40, and it is negative because they are moving the same direction, this one. So we have another equation, this one. So we have the three equation here. This three equation you can use simultaneous, rearrange and use simultaneous equation to obtain current 1, current 2, and current 3. Now you can use the concept of what I show you to solve, to find current, this current 1, current 2, and current 3. Use the same procedures as I show you here, this one. Make sure you follow the Kirchhoff voltage law, Kirchhoff current law, and Kirchhoff the two laws, this one, to calculate the current moving in this direction. Here are some solution here, so you can move with me, you can check here these loops, select the loops. We have two loops here, then after solve to obtain current 1, current 2, and current 3. Thank you very much for watching my video. Don't forget to subscribe, like, comments, and if you have also another many questions, you can drop there with comment. Welcome and be blessed a lot.